In this video, we're going to look at adding and subtracting radicals. All right, so just quickly, if this video helps, be sure to like, subscribe. You can throw in a comment, whatever you need to do. All right, so now, adding and subtracting radicals. First of all, we all know a radical is like a square root or a cube root, something like that. And I've done previous videos on simplifying radicals, so if you want to go check those out, I would do that. But what we're going to look at today is, let's say we have 2 square root 3 plus 4 square root 3. If we were adding these two radicals, how would we go about doing that? So here's the best way I know to explain it, just to make your life easy. Imagine that this square root 3 is like a variable. Okay, so 2 and 4 are coefficients, but let's treat the square root of 3 like it says x. All right, so let's make this 2x plus 4x. Well, I imagine a lot of us know how to do this. We would just combine like terms. So these are like terms since they have the same variable. Essentially, for radicals, you have to have the same index. So it has to be like a square root and a square root add together. And then you need the same radicand, which just means what's under the square root. All right, so just like in this situation, 2 square root 3 plus 4 square root 3, we can add that just like 2x and 4x. All right, so let's get rid of all this and I'll show you how it looks. So if we were to add 2x and 4x, obviously we would get 6x. But now let's do the same thing, or apply the same process to 2 radical 3 plus 4 radical 3. Well, that's going to give us 6, and then instead of x, we're going to have radical 3 or square root 3. So that would be our answer. Like, let's do another one. So we could do, let's say we have 5 square root 6 minus 3 square root 6. All right, so once again, we're just seeing if we have like terms, and for radicals, like terms means the square root has to be the exact same, which it is, and then what's in the square root has to be the exact same, which it is. So then we can just combine these like terms with the coefficients. So we say 5 minus 3 is 2, and then we keep the square root of 6. All right, now here's an example of when you can't combine radicals. Let's say we had 2 square root 3 plus, we'll just use the one from the last problem, 5 square root 6. So if we were to be given this problem, there's nowhere for us to go. We're basically stuck here, all right? Because both of these are square roots. Both of these radicals are square roots. However, what's under the radical is not the same. So we can't add these together, all right? Now let's do the exact same thing with, let's say we have the square root, we'll say 3 square root 5 plus 2 cube root 4. All right, now here we have the same situation. We cannot combine these two terms because this is a cube root and this is a square root, which means the index is not the same, so these are not like terms. All right, so that's the quickest version of this that I can give you. Now, let's look at a more complex problem. Like, let's say I gave you 3 square root 27 minus 2 radical 12. All right, now, a lot of people may look at this, especially if they're just being lazy and trying to go fast, and they'll say, well, both these terms have a radical, but what's underneath the square root's not the same, so we're done. We can't go any further. However, here's what you have to watch out for. Sometimes you may have to break down the radical, then add or subtract. And that's exactly what happens here. If we break down these two radicals, it could be the case that we break down 27, or the square root of 27 and the square root of 12, and we still can't add these. But it could be the case, well, subtract these, but it still could be the case that when we break these down, we may end up with a number under these square roots that are the same. So this is a more advanced problem because we have to break these down first. Once again, I've uploaded a video over this already, but I'm going to go ahead and do this. But once again, if you need a slower explanation, go back and look at that video. So 3 is going to be on the outside times, let's see if we can break down the square root of 7. Or 27. So we're going to use 9 and 3 because 9 is the biggest perfect square here that divides 27. So then that's going to give us 3 times 3 radical 3, which is 9 radical 3. So that's what we have on the left. Now we're going to subtract that by, and we're going to do the exact same thing with 2 radical 12. So we've got 2 times, let's see, we can break down the square root of 12 with the square root of 4 and the square root of 3. And then we've got 2 times 2 radical 3. So we've got 4 radical 3. So now, when we're here, you can see at the beginning, the square root, what was under each square root was not the same. But when we simplify, we actually do end up with something that's the same. And that's more of the advanced problem here for you to complete. So now we've gotten 9 radical 3 minus 4 radical 3. They're both square roots. Both of our radicals are square roots. And the radicand, which is under the radical, is both of these are 3. So we can actually combine these like terms. We can say 9 minus 4 is 5, and then keep radical 3, and that would be our answer. All right. I will do, let's see, I'll do one more. I'll do an advanced one again just to give you an idea. And actually, I'll do a cube root just to mix things up. All right, let's say we have the cube root of, well, 7 cube root 3 plus 2 cube root 192. All right, so once again, I've uploaded a video on breaking down radicals, so I would be sure to go check that out, because we're going to need that here. We have the cube root of 3, and that's obviously different from the cube root of 192. However, if we break down the cube root of 192, we might end up with something that we can actually combine here. So this is actually broken down as far as it will go. I can't find a perfect cube that divides 3. I mean, 1 would work, but it wouldn't really do us any good. So let's focus on 2 times. Let's see if we can break down the cube root of 192. All right, the biggest perfect cube that divides 192 would be 64, and then that would leave us with 64 times 3. So now we can do the cube root of 64, which is 8. The cube root of 64 is 4. My bad. Getting my cube roots and my square roots mixed up. All right, so now we have 2 times 4, cube root 3, which gives us 8 cube root 3. All right, so now if we bring down 7 cube root 3, you can see that we have, in both of our terms, we have a cube root, and then what's under the radical, or the radicand, is the exact same, which means we can combine these. So we can add the coefficient, 7 plus 8, which is 15, and then we get cube root 3. All right, so once again, this is all over, or this has everything to do with adding and subtracting radicals. What you need to happen is this. You need your index to be the same, so it has to be a square root and a square root, or a cube root and a cube root. And then you have to have the same number under the radical, so that also has to be the same. So the best way to memorize it is same index, same radicand, and then you can combine the coefficients, and you can leave your radical just like it's a variable.